In this video, we're going to look at integration by substitution with limits. So we can see we've got a function 4 plus sine x and its corresponding derivative cosine of x. So what I'm going to do is going to write let u be 4 plus sine x. So du by dx, the differentiation of 4 is 0, the differentiation of sine x is cosine of x. So du is cosine of x dx. So the problem here is we need to change the limits. So we're going to write change of limits. And say when x is pi over 2, we get u is 4 plus sine pi over 2. Well, sine pi over 2 is 1. So 4 plus 1 gives me 5. So when x equals 0, u is 4 plus sine 0. Sine 0 is 0. So 4 plus 0 is 4. So now our integral will now become the new limits of 5 and 4. Cos dx is now going to be du. 4 plus sine x is u. So we could rewrite that as the integral from 4 to 5, 1 over u du. And the integral of 1 over u is ln mod u. So we get ln mod u, treating limits of 5 and 4. So we get ln 5 minus ln 4. From the laws of logs, we can divide them. So ln 5 over 4 is the answer. Here we've got another question. So what I'm going to do is make u to be 1 plus x squared, du by dx is going to be 2x because the differentiation of 1 is 0 and the differentiation of x squared is 2x. So du is 2x dx, half du is now going to be x dx, and again we need to change the limits, so change of limits. So we can say when x equals 2, u is 1 plus 2 squared, which is 5. When x is 1, u is going to be 1 plus 1 squared, which is 2. So my integral now becomes, the upper limit is 5, the lower limit is 2. So x dx is now going to be a half on the outside, du on the top. 1 plus x squared is u. So a nicer way of writing this is a half on the outside, limits of 2 to 5, and we're integrating 1 over u du. So we get a half ln mod u between 5 and 2, and that's now going to give me a half ln 5 minus ln 2. So from the laws of logs, we could write that as ln 5 over 2 times a half, and that's the answer.